Artificial intelligence, commonly referred to by its acronym AI, is a set of computer-based technologies that can mimic human intelligence to a certain degree, utilizing human-like intelligence to work with language, recognize and produce images, solve problems, and make decisions. Computer hardware and software, which previously used rule-based logic to carry out automated tasks, have now made significant progress. Not only can it mimic human intelligence when dealing with language, images, problems, and decisions, but it also surpasses human intelligence in terms of speed and the amount of data and knowledge it can process as part of its artificial thinking and reasoning. I emphasize artificial thinking and reasoning here because AI is more about statistical pattern matching rather than carrying out conscious thinking and reasoning. As you are now seeing with various products, you can give AI systems loads of text or images, and not only does it understand language, objects, and context within images, but it can also use them for problem solving, decision making, and to generate new content in the form of coherent responses and new images. With a combination of different technologies and techniques, AI can expand its understanding of language from text to also spoken language, as well as understanding and recognizing various types of sound. AI that generates content, sometimes referred to as generative AI, can also produce, in addition to text and images, speech, sounds, and even videos featuring images, sounds, and speech that flow coherently. You can see that AI is human-like intelligence, operating at breakneck speeds that enable it to pattern match and produce language, images, as well as mimic human-like reasoning to problem solve and make decisions. What has contributed to this advanced progress of AI? The first are tools and techniques that fall under the category of machine learning. They have given computers the ability to learn from massive datasets using algorithms that help identify patterns in data and make predictions. Advancements in machine learning have led to significant progress in natural language processing, also known as NLP. Thanks to NLP, machines can now understand, interpret, and generate human language, often by harnessing the predictive power of machine learning and applying linguistic rules. This capability has further propelled AI development, allowing us to interact with intelligent systems more naturally through language. Advancements in computer vision have enabled AI systems to interpret and understand visual information. AI systems can now recognize objects in an image. The key lies in converting images into numerical data, pixels represented as number arrays, and then applying machine learning algorithms to detect patterns, features, and relationships within that data. The other breakthrough has been not only converting data into computer-friendly numbers, but also consolidating, condensing, and reorganizing these massive datasets into neural networks. Using machine learning algorithms, data and information are condensed into interconnected nodes, inspired by how our brain organizes information and memory. These neural networks are at the core of what we now know as AI models. The process of using machine learning algorithms on massive datasets to create these neural networks, i.e. the AI models, is now known as training on datasets. Many of these amazing concepts, techniques, and algorithms have existed for decades. The human brain should not be underestimated. We've known the theory for decades. There has been another ingredient that has accelerated the recent progress of AI, and that is the use of graphics processing units, better known as GPUs. GPUs provide remarkable parallel processing abilities, which are typically used for graphics, but are now also utilized to run machine learning algorithms and technologies to produce and run these AI models consisting of complex neural networks. Let's examine an example of how a predictive AI model is developed. An AI that can predict data by looking at patterns within existing data. To create the AI model, large amounts of datasets are processed to recognize data patterns in existing data and how they relate to the data being predicted, which may be some event. For example, we might have datasets on users' music listening habits, and we create an AI model using that data that can predict what other music you might like by looking at patterns in your existing playlists. Alternatively, it might be an AI model created using travel insurance records to predict future travel destinations for customers with the purpose of targeted marketing. Internally, your existing data is fed through the neural network to detect patterns and determine where these patterns ultimately lead. For the music playlist example, this might be a new song you'll like, and for the travel insurance example, it might be a new holiday destination you'll enjoy. Large language models such as ChatGPT are all created similarly. We extract vast amounts of text from books, databases, documents, and web pages to develop an AI model that can predict the correct text-based response, word by word and sentence by sentence. To us, the coherent response to our prompt feels truly magical, but in reality, it is still just an AI model trained with vast amounts of data, enabling it to predict what text, i.e. words and sentences, makes sense as a response to each aspect of the prompt. The same is true for computer vision AI models. We utilize massive datasets consisting of images and corresponding labels to annotate objects or features within the pictures. Machine learning technologies and algorithms convert all these images into numeric datasets where data patterns can be associated with the provided labels. The created AI model can then identify objects within new images presented to it. In reality, even these images are converted into numerical representations, and patterns within the numerical data are recognized again by pattern matching through the neural network, eventually leading to an object label. So next time you see an example of an AI service or application that recognizes cats or dogs within a picture, you know what's happening. The same applies to AI models trained either to recognize sound or replicate sound. The model is created by training on vast amounts of audio samples. This type of model enables services like text-to-speech, where a model allows you to clone a specific kind of voice and then convert text into spoken language. I've obviously oversimplified all the mechanics involved, but our trained neural network can both understand text and its relationship to sounds to create the cloned voice. Now that we know what AI is and its enabling technologies, should we be worried about losing our jobs? The good news is it's a tool that leverages existing knowledge, and that's both its advantage and disadvantage. In our dynamic world, AI can assist with approximately, as a guesstimate, in 75% of existing repetitive tasks. However, in a changing world, there's always something new that the AI model hasn't yet been trained on. An overlooked aspect is that human intelligence is always required to utilize both human intelligence and intuition to connect the dots, especially in unknown areas. You do, however, need to be that competent employee or individual who can work in the unknown 25% area, as inevitably teams will be reduced in size, because with the addition of AI, one individual will be able to do the work of one or more people. The good news is that AI doesn't always understand context, has no real intent, nor does it engage in conscious thinking. It's a swift pattern matching tool that produces an output. Therefore, the good news is that most of our jobs are safe. This has been Rag Diamond, and thanks for watching this video on What is Artificial Intelligence, a video which is part of my AI Basics series. Please remember to like and subscribe. Your support will be greatly appreciated.